This is an independent project for the ME 3210 Design and Manufacturing course at Georgia Institute of Technology for Dr. Rashidi. This video covers the design prompt, a design proposal, concept graphics developed in SOLIDWORKS, manufacturing processes, material use, and product analysis. The project task is to improve a product that is widely used by people and focus on developing an aspect of its design, like human factors, ergonomics, and ease of use. The thought here is that many objects in motion lack an indication if that motion is straight, vertically, or horizontally. A prime example of this is the difficulty to cut straight with scissors. Levely, the product developed for this project, is a response to this issue by shrinking a spirit level, which is used in many fields like manufacturing, construction, and home improvement, into an attachment that can be mounted onto common household items, like scissors from the earlier example. So why is this attachment desirable or needed? Well, it's clear that people in industries requiring heavy use of tools will already have a level or other instruments to ensure clean and straight motion, but these will not be found in the average household. This product serves as a multi-use indicator of straight motion with the ability to attach to various objects and provide the functionality of a spirit level in a small form. Here we can see a SOLIDWORKS visualization of what Levely would look like once manufactured. On the left, you see a typical spirit level, a vial filled with alcohol or oil of some kind and not completely filled so that there's a bubble that forms in the middle in between these two solid black lines. These are indicators to tell you that when this bubble is in between these two lines, the orientation of your entire product is level or straight. On the right side, you'll see that this pad where you rest the object that the Levely mounts to. On the other side of the product, we have a 440 thumb screw that goes through a 440 heat set insert. And on the other side, to prevent damage to the object that Levely mounts to, we have a rubber bumper. Because the original inspiration for this product was my personal experience to cut straight with scissors, especially as a left-handed person who was often using right-handed scissors, we have a visualization of what Levely would look like once mounted to scissors. As you can see, this is not a product that would obscure too much of the motion that would need to happen when cutting scissors. As you can see, the scissors would still be able to fully close with this mounted to the front handle. And from a bird's eye top view, we can see that once your cutting is no longer straight, for example, if your cutting starts to stray off to the right, this bubble will move out of these two black lines, serving the purpose and functionality that was initially intended for this product. In a situation where you would need to have a tracker of straight motion in a different direction, we have an alternate configuration of Levely. So in this situation, the spirit level vial is vertical and you have a mount that's parallel to the spirit level. And here we have the same components, a 440 threaded insert, a 440 threaded bumper, and a thumb screw. We can take a look at the schematic of Levely to further discuss the components that make up the full assembly, the materials that would be used, and the overall dimensions of the product. With the largest dimension of Levely being a length of 2.66 inches, this is not something that is likely to get in the way of any applications you're going to use this for. It's, for example, previously shown with the scissors in the assembly model. Levely does not at all interfere with the cutting or the motion of the scissors. And because it's such a small product, even in other applications, it's very unlikely that it will interfere visually or in the function of the tool that's being used. Additionally, we have a BOM listing the parts here. So the thumb screw is just a stainless steel thumb screw. The bumper is a rubber bumper, specifically polyurethane rubber. And the heat set insert is made out of brass. And then all this light gray material that you see holding the spirit level vial and also holding all of the threaded parts, or at least aligning the threaded parts on the right side, this will all be 3D printed with ABS filament or plastic, just because it's a better alternative to PLA when you need something to be more heat resistant. And it's better to take that safety precaution so that this lovely product is more compatible with more uses or more applications. So in a situation where your tool would heat up from friction or just be in a high heat environment, this would not fail during the application. Additionally, because of the small dimensions, again, the length of this lovely product is 2.66 inches, and relatively small and lightweight components, this is also unlikely to weigh down your tool or weigh down your hand or your arms when using this for both short or long periods of time. So let's take a step back and look at the positives and downfalls of Lovely. The first positive we have is that this is a low-cost product to manufacture. The 3 commercial off-the-shelf parts that we would need, the thumb screw, the rubber bumper, and the heat set insert, are all $3 or less on McMaster. The second positive is that this product is compatible with a lot of applications because of the flexibility that the thumb screw provides. It being able to move in and out allows us to use tools of different or a wide variety of diameters or widths with the attachment. And then the last positive is that the largest component that we are making for this is the 3D printed case that holds the vial and the parts. The 3D printing involved for this would be a very short process, especially because the product is at max 2.66 inches long. The downfalls, however, are that we do need 2 separate configurations depending on if you want the spirit level vial to be parallel or perpendicular to the tool that's being used. The second downfall is that once you start using larger tools, we start having a compatibility issue. However, this product was not initially intended for large machinery that you would find in a factory or assembly line. This is just for everyday household use. And then the third negative is that once you start using significantly small tools, this product would or may start to obscure vision. Finally, we have references. I used a slides template for SlidesGo for the presentation, and then I took a few models online and images, which are all listed here. Thank you.